Hey, it's Professor Davis, and I want to take a look at some of the properties of quadratic functions. This is a lot of the things that we studied in section 4.1. So let's take a look at one of these, and we can use our calculator to verify some of our solutions and verify some of our calculator stuff using algebra. So here's what we want to do. We have this function f of x equals negative 1/2 x squared plus 6x minus 5. And here's what we want to do. First, let's graph the function and find the coordinates of the vertex. We'll do that both algebraically and graphically. Determine the coordinates of the y-intercept in part B. And then we'll write f in the standard form. That's where it's sometimes called the canonical form of the quadratic equation. We'll write the equation for the axis of symmetry, and we'll make a graph of that. And then we'll finally write the domain and range of f, knowing what we've gained in the first parts of the example here. So let's begin by graphing the function, getting its coordinates, and then verifying that algebraically. So I took the liberty of entering our function f in my calculator in y1. Now let's just go ahead. We're not sure what the viewing window might be, so I'm just going to go ahead and hit zoom in 6 and get a graph of it. Now take a look at this graph. It's really not what we call a complete graph because it doesn't contain all the features of the function. We do first see the y-intercept, that's good. We don't see the vertex, that's way up here kind of off the screen. We're going to have to adjust our viewing window for that. And we also don't see the right-hand x-intercept, so we want to be able to see that too. So let's go ahead and adjust our viewing window accordingly. Now our x-min is fine, but our x-max has to be a little bit longer, further to the right, so that we can find that rightmost x-intercept. So I'll change the x-max to 15, and allow me to change the x-scale to 2, just so all the tick marks aren't all cramped up together. The y-min is okay at negative 10, but the y-max, remember, that wasn't quite tall enough to get the vertex, so I'll change that to 15, and we'll go ahead and change the y-scale marks to 2. So as we look up the y-scale, past the x-axis, the increments will be like 2, 4, 6, 8, and so forth. Now notice when we graph the function take a look at it. Well, we have the complete graph of the function. We have the y-intercept, the two x-intercepts, and we have the vertex. Now we want to find the coordinates of the vertex. First note that the quadratic coefficient, here it is, negative 1/2, that's the quadratic coefficient, is a negative number, and that's why the graph of the function opens down. Consequently, the vertex will be a maximum value. So to get an idea of what its coordinates are, I'll go to the Calculate menu, Super Valuable menu on our calculator. We get to that by hitting the second key and then Trace, the Trace button. And since the graph opens down, we want to find a maximum value. That's option 4. So notice when I scroll down and hit enter on number 4, or I just press the number 4, it asks me to give a left bound. That means put in any number that is to the left of the vertex. And then it asks me for a right bound. Find any point on the graph that's to the right of the vertex. So I'll just use the cursor key, cursor over to the right of the vertex, hit enter again, and then it asks me to enter a guess. It doesn't have to be a great guess. I'll kind of do a bad one here. I'll go ahead and hit enter, and now let's take a look at the output. Now your output might be a little bit different than mine, depending on what guess you put in and your left and right bounds. Notice the kind of the limitations of the calculator here. The y-coordinate is clearly 13. The x-coordinate, though, is a number super close to 6. So we surmise that our vertex might be at the point 6, 0. So let's go ahead and verify that now algebraically. Now we know that the x-coordinate of the vertex is in the form minus b over 2a. B is the linear coefficient, a is the quadratic coefficient, so in that case 6 is our linear coefficient, negative 1/2 is the quadratic coefficient. If we simplify the denominator, we have 2 times negative 1/2 to get negative 1. So we have negative 6 divided by negative 1 to get 6. That's the x-coordinate of the vertex. To get the y-coordinate, we simply plug in that x value into our function. In other words, evaluate f at 6. And if we do that, notice here we have negative 1/2 times 6 squared, so that's negative 1/2 times 36 to get negative 18. 6 times 6 is 36, and then if we subtract 5 and combine all that, negative 18 plus 36 minus 5, we get 13. So that gives us the coordinates of the vertex. Now in part B, we wanted to find the coordinates of the y-intercept. And again, we can use our calculator to help us get that. If we go back to the calc menu, that's the second key and the trace button. Notice here the very first option says value. So that means give me a value for x, I can find the functional value for you. So I'll go ahead and put in 0 for x and hit enter. And notice when I do so, we get negative 5 for the y-intercept. And that's no surprise. Here's our function, and then our constant on the end here is negative 5. That tells us what the y-coordinate of the y-intercept is. So there's our y-intercept, and we can also verify that algebraically. And let's take a look at that real quick too. So to get the y-intercept, we evaluate f of 0. That's what we did in our calculator. And there we have f of 0, and we get 0 minus 5 to get negative 5. And then in part C, we want to write the equation in the standard form. Now let's think about that before we do it. A is the quadratic coefficient. That's the same no matter if it's written in the polynomial form that we're given, or whether we have the standard form here. H and K are the coordinates of the vertex. We found that in part A. So we can simply fill in these numbers now. And if we do so, notice we get f of x equals negative 1/2 times x minus 6 quantity squared plus 13. So we can simply find the vertex using our calculator to help us, and we can also use that formula to find the x value of the vertex, and that way we don't have to do completing the square to find the standard form. So it's really a bit easier for us to do it that way. Now in part D, we want to find the axis of symmetry. Now we know that the equation of the axis of symmetry is of the form x equals a, we call it, where a is simply the coordinate of the x-coordinate of the vertex. Actually, we might want to call that h instead, just to be a little bit more specific. So that's 6 in this case. So look, here's the vertical line, x equals 6. Here's our graph of the function we had, negative 1/2 x squared plus 6x minus 5. And so there's our axis of symmetry, meaning the graph is a mirror shape of itself about that axis. And then finally, we want to find the domain and range of the function. The domain of any polynomial function is the whole real line. In other words, the domain is negative infinity to infinity. To find the range, well, that's where we make use of the vertex. Notice here the y values can't go past the vertex, which is 13. So all of the y values, all of the function values have to be 13 or less. And if we want to write that using interval notation, to write 13 or less, we would write negative infinity to 13, closed on the right side, and of course, since we have infinity, open on the left side. So that's how we can explore some of the properties of quadratic functions using our calculator with algebra backup.